All right, so 1.4 is all about distributing and combining like terms in polynomials. So first, let's identify all of the parts of a polynomial so that way whenever I say a term or a coefficient or whatever, you know what I'm talking about. First of all, I'm sorry on this diagram it has like name, period, and this. Just disregard all of that. Okay, so on this, let's start with the top part. So this first blank is pointing at your exponent for your first term, which is called the degree of the polynomial. So most of the time it's your first exponent that's listed, but if it's not listed in standard form or in order, then it's going to be your largest exponent. Okay, so this is a third degree polynomial because the largest exponent is 3. Okay, so now all of these circles are your coefficients. And that is the number in front of your variable. Okay, so your coefficients are the numbers in front of your variables. And now this next part, at the bottom, this is your term. And so a term is broken up with plus and minus signs. So this is a term, and so on. So this one has 4 terms. Okay, and then the last piece is the number without a variable, which is called your constant. And we'll just write number without a variable. And it's usually, if it's written in standard form, it's at the end. Okay, so those are all of the parts that we're going to be talking about with these polynomials. So now let's talk about what are like terms. So like terms are terms with the same variable, oops, that's not how you spell with, the same variable to the same power or your constants. And I'll explain what that means in just a second. Make sure you get that written down. So it's like terms or terms with the same variable to the same power or your constants. Okay, so let's draw a line connecting your like terms from the top row to the second row. So on this, you can see there's a couple different variables. There's x, y, and z. So remember, it has to be the same variable and the same exponent. So for 4x, its like term would be 7x. Okay, and then let's see, I'm going to go 17. That doesn't have a variable, so that's called your constant. And remember, all constants match, so it would be, goes to 11. Those are like terms. Then I have 6x squared. I don't see any x squareds in the bottom row, so that one's not going to have a matching one. And then I have 19y to the 5th. So I'm looking for another y to the 5th. Oh, and look, I have just a regular y to the 5th. And then 75z. Well, I see something down here with a z in it, but that's z squared, so it has to be the same exponent, so that's out. And then it looks like my last one, y, matches 4y. Okay, so those other ones are not like terms. Even if they have the same letter, doesn't mean they're necessarily like term because, again, their exponent must be the same. Okay, so now we are just going to be simplifying, aka combining like terms. So there's several ways you may have been taught to do this. I like to underline what is the like terms. So on this one, I have 2x, and what's 2x like term? Well, that's going to be 8x. And then the constant, so I have -4, and I'll do a squiggle, and +3. Those are like terms. Okay, let's go ahead and combine your x's. 2x plus 8x, and you add their coefficients, so 2 plus 8, and that gives you 10x, and make sure you have the x with it. And then you have -4 plus 3 would give you -1. Can you combine any further? You always should check for that, and the answer is no, because you have a constant term, which is the 1, and you have a term with an x in it, and those are not like terms, so that's as far as you can go. All right, now let's try letter B. So I have 4y, and that goes with y, so those are like terms, and then negative 3x and negative 6x. Good, so let's do the y's first. Sure, it doesn't really matter. So this 4y plus y would be 5y. Let's do our x's. Negative 3x minus 6x. So negative 3 minus 6 would give you negative 9x. Okay, another way you could write it is if you decided to combine your x's first. You could have flip-flopped it and had negative 9x plus 5y, and that would have worked just fine. It doesn't really matter. Honestly, this answer is better, the bottom one, because usually the mathematical etiquette is to write them in order from the alphabet. So x comes before y in the alphabet, so usually you write them that way. But if you don't, for this class, it doesn't really matter. Okay, so let's go ahead and try this one. If you want to pause the video and try this one by yourself, that'd be great. Okay, did you actually do it? Probably not, but that's okay. So I'm going to combine my x's. I have a 3x and a 9x, and then I have 5y, 7y, and negative 4y. So there's 3 terms on the y's. No big deal, we'll be fine. So 3x plus 9x, 3 plus 9 gives you 12x. 5y plus 7y minus 4y. You can choose. You can either do it all at once, which is what I'm going to do, or you could do 5y plus 7y and write 12y minus 4y, but then you're just going to have to redo it again. So I wouldn't do that. Let's just do 5 plus 7 minus 4, and I believe that gives you positive 8y. Okay, double check. Can you combine? No, because those are x terms and y terms, and they are not like terms. Okay, one more. So this one I have p squareds, an r square, and an r. So let's see, negative 7p squared and negative 8p squared go together. What about the r's? The answer is no, they do not go together because one is an r, so that's its own set. And then r squared is its own thing, so like it's different. They're not like terms, r and r squared, because they don't have the same exponent. So you can't combine them. So let's go ahead and do it. So let's do negative 7p squared minus 8p squared. So the squareds, don't let the squareds mess you up, excuse me. And so it'll be negative 7 minus 8, which would be negative 15, and then I'm just going to keep it as p squared because that's what it is. And then you have choices. Since we can't combine those other two, I'm just going to drop them down. The order doesn't really matter either. You can flip-flop this any way around, technically, as long as the negative sign is in front of the p squared, 15p squared, and then there's plus signs in front of the other two. So I could rewrite that in any order. All right, now one of my favorites, the distributive property. So you've probably seen this before, and that's okay if you haven't. So it's, I've made this real mathematical term called a swoop. And what you're doing is you're multiplying. So when you do A, when you distribute it to the B, that's A times B. And then you distribute the A to the C, so that would be plus, because there's a plus sign right there. That doesn't always, but okay. A times B plus A times C. Okay, and that's what the distributive property is. So let's go ahead and do a couple. So we're gonna go ahead and distribute. And I found that if I multiply as I go and don't just draw both things at once, I'm less likely to make a mistake. But you could be different. So 3 times x gives you 3x. 3 times positive 2 would be positive 6. Double check. Can you combine like terms? The answer is no. So that's your answer. Okay, let's try B. So let's go ahead and multiply. Oh, I just told you not to do that. So 4 times 2x would give you 8x. 4 times negative 6, since it's negative, it would be 4, a positive times a negative is negative, and then 4 times 6 would be 24. Can you combine? Nope, so that's it. All right, this one we got to be careful because you have negatives and everybody makes mistakes on negatives, myself included. So just go slow, and if you need a calculator, there's no shame in the game. So we are going to distribute negative 3 times 7x gives you negative 21x, because negative 3 times 7. Be careful, negative 3 times negative 1 is positive 3. And then what do you do with this plus 8? Do you distribute like that? No, you only distribute to what's in the parentheses. So I'm just going to drop that plus 8 down. And now I'm ready to combine like terms. So I've got 3 and 8. And then the x is just by itself, right? There's no other x terms. So it's going to be negative 21x. And then go ahead and add those, and that gives you positive 11. All right. Ooh, we're getting real crazy now. Okay, so we have to distribute twice. Not a big deal. It's going to be the same, so just take your time. So 5 times x gives you 5x. 5 times negative 4 gives you negative 20. And then negative 2 times x. So, and don't forget there's a negative sign with that too, because it is negative 2. So negative 2 times x is negative 2x. Negative times 2 is negative 4. All right, looks like we have some like terms to combine. So let's combine 4x and negative 2x, and then your two constant terms. So I'll do the x's first. 5x minus 2x gives you 3x. Be careful, negative 20 minus 4 would be negative 24. You can't combine any further than that. Okay, I believe, I don't know what that is, but I believe that is it for the notes. So thanks for watching and have a great rest of your day.